So this will be a bit of a diversion for you. Because this maple syrup thing is near and dear to me, I tend to see connections. And I started doing maple syrup as a hobby 17 years ago, turned it into a commercial enterprise about 10 years ago. And as I started to think about this presentation about mobility, functionality, I started to see the connections between how I collect sap and how we manage roads. Really. So the challenge today, take a very basic principle, present it to you, professionals, people with experience, hopefully in a way that makes you think about it perhaps a little differently, at least in a diversionary way, help you get through this next half hour in an alert fashion. There will be no formulas or algorithms for you to memorize. I am a functionality hound. Defining purpose of a system, defining the purpose of the pieces of that system, making them work, being committed to do the work so that they work as designed, being willing to make hard decisions for each piece of that larger system is critical for that system to work, be it a tubing system or a highway system. I can't force 1,000 trees worth of sap through a 5/16 line. It just doesn't work. We can't make a roadway that's designed as a local road to work as local access, work as an arterial. If we try, we'll have problems. We'll have significant problems. And we'll be wasting public resources in the process. Any traffic engineers sitting in here? How many of you see the clear connections between flow dynamics and your traffic modeling sequence if you're doing traffic modeling? If you look at those models, it just looks like liquid moving through a system. And where you have restrictions, it's pretty clear this stuff moves where there's least resistance, and if you get resistance, you get backup. Next will be a slide that I'm sure you're all very familiar with, but I've changed it. It's not arterials to locals. It's wet and dry lines to lateral lines. We will get to highways, by the way. I'll get there. This is a diversion. Just back up a little bit here. So I'll start talking about things from the bottom and work my way up. Lateral lines, my connections to trees. And I don't know if it's possible, AV man in the back, if we could dim lights at all, if that's possible, just so that folks can see these images. So the lateral lines, like the local road system, are set up for access. They are where the connections happen to the trees. My system is, I tap about 3,000 trees. And the process, if you can imagine the old historic way of doing this, is you hang buckets on trees. Well, pretty inefficient process unless you have an army of people. I'm trying to do this as a family business. And so I put together a system, a vacuum system with tubing that does my collection. Efficiency is critical. So like a local road, this is made for connection to this system. I can fit about 7 trees worth of sap into a 5/16 line and keep good vacuum out to the end of my system, to the end tree. If I put 10, 12, 15, I'll still get sap coming out of that thing, but my end tree, instead of having 25 inches of vacuum, I'll be down to 10 or 15 if I overload that thing. So here's another challenge for you. As I'm talking about this, think about how that applies to your road system. There's a lot of parallels here. I'll let you free think through that process. Another issue that I have, it's not necessarily accidents as we would normally think of them. Mine are different. It's a squirrel that decides to climb that tree and chew on the plastic, or a bear that decides that that would be a fun toy to play with. If I get those type of accidents or those type of issues happening in the system out here, because of the flow restriction in that small line, my overall system still functions really well. I can lose one of these 5/16 lines, and my overall system will maybe drop 1 inch of vacuum. I'll go from 25 to 24. It's enough for me to know I've got a problem so I can go out and fix it, but the whole system still is functioning really well. The next piece of my system is my collector system. In the tubing world, we call them the main lines. These are typically 3/4 inch or 1 inch lines that all the laterals feed to. So I think that's my laser. So these are the lateral lines you can see coming in from the woods that they connect to the main line. There's no direct connection from these main lines to the trees. The reason is, if I go back a slide, this makes up by linear feet about 80% of my entire tubing system is this type of a tube. If I go here, I'm at about 10% of my tubing system, maybe 12. But all my connections come to that. That way, if I have failures in the lateral line system, I don't lose significant vacuum, even to the trees just downstream from it, because there's enough vacuum transfer through that main line to compensate for it. So the collector works really well. If Mr. Bear bites this line, I've got a more significant issue. My vacuum will go from 25 to about 20. The system still functions. I probably lose about 10% production that day, but I'm still making syrup. So this is where it gets a little goofy. This is where I've got 2 main lines coming together, feeding into a dual line system. So when my system is reaching capacity, I don't take 300 trees worth of sap and 300 trees worth of sap and try to just push them through a little bigger line, because at this junction point, there's going to be a wave. Sap is coming together. There's a wave of sap that goes uphill, goes downhill, and can actually, if it's a good sap day, it can actually fill the line at that point until the sap moves downhill maybe 50 feet and it starts to level back out. And we've seen that at our intersections. You get wave effects upstream and downstream from our intersections. And so I've got functional area of an intersection right there. My workaround is this upper line isn't designed to carry sap. It's purely vacuum transfer. So I connect that up beyond those junction points where the wave impacts hit. So I always have good vacuum transfer working back uphill to the trees. Another critical part of this is speed differential. I mean uniform slope, so my sap flows evenly. But we've heard that a few times in the last couple days. Speed differential, as opposed to necessarily access points, is a critical factor in our safety issues that we have around intersections, driveways, public roads, whatever. So speed differential also is critical for me. I try to keep everything at a very uniform slope, space out my connection points so I don't have those waves running into other waves, creating blockages in the system. So we're shifting from collectors to arterials right there. And then here's my freeways. These are lines that have no direct collection tied to them. It's all main lines coming together into big transfer lines. So the black lines are purely for transferring vacuum out into the woods to those dry lines. And then the other lines are for just sap going to collection points. And again, uniformity is critical for this to work well. It's your freeway. It's where things come together. I don't have T-fittings. I have 45-degree angle fittings, so I have less wave impact going upstream, as you would with the merge on a freeway. I run about a 2%, maybe a 3% slope on these. If I get to a downhill stretch, that line can get way up in the air because it's just critical that I don't have accelerating and then decelerating sap, things moving around. I'll get the sap actually having turbulence where I'll watch the sap tumble. Let's say a tree falls across this. It happens all the time. I own 4 chainsaws. Tree falls across this, creates a low spot. The sap goes in there, and it doesn't just with that vacuum move along and climb up over the hill, just like we would experience with some disruption in our system. You're going to have that speed differential, turbulence, people moving around each other. You get a mix. For SAP quality, I don't want that. I want stuff to move into the system and move out of the system as quickly and as efficiently as possible. So there it is. I've got arterials, I have collectors, I have a local road system with connectivity out to the trees, and it functions really well. Properly classified, properly designed arterials, collectors to carry that sap, and then good connectivity without overloading those things out to the trees makes it work. And I got a nice functional system. So here we are back to reality. The diversion is over. And I'm assuming everybody has seen some version of this type of a display. And many of you have a lot of years of experience. I'm assuming there's a few that don't have a lot of experience in this realm. So I'm trying to do the dance between those things, your levels of experience. Our challenge is to clearly define from an overall system perspective how each highway should function, just like I do with my tubes. There needs to be specific function, and that needs to be balanced in that mobility and access spectrum. Beyond that, we need to identify what tools we're going to use to manage those systems, and we need to be able to implement them. And there's a lot of challenges in implementation. We need to be able to communicate in a persuasive way. Policy, legislative action comes back to bite us if we overuse tools, if we don't use them properly. So we need to be able to communicate both to our folks who are doing permitting and working with the residents who are asking for a field access for their farm field, all the way to when Mr. Sobotek calls us and says, what are you doing on that corridor? And therefore the language that goes to our legislators as well. We need to learn to be persuasive in communicating our needs for the tools that we have to manage our system. You can see we've divided our tools into basically two categories. Proactive tools, which are corridor-wide for implementation. How are we going to have statutory, or how are we going to implement these statutory tools that we have for freeway, expressway type designations and the tools that come with that. More of the police powers type controls down to our permitting controls. So we have proactive and reactive that our group works with. And just a little summary slide of kind of what we've been talking about, appropriate function and mobility goals. We need to define those things. We need to be thoughtful and systematic in the way we put together our system. We need to think about the tools that we need and the tools that we can use to manage for that overall goal. And then we have appropriate safety expectations, because our corridors are going to have different safety results based on our ability to manage per the design and the public investment that comes behind that. And it's cyclical, you know, each is driving the next. But I think safety is really an outcome of our ability to manage functional goals and using the tools properly. Here's a graph. This is probably not news to a lot of folks who are in this business, but for those who maybe not that familiar with it, it is interesting to see where the majority of our fatalities happen. And this graph is based on hours of exposure rather than vehicle miles traveled, just a little different way to look at it. Interestingly, our major arterials are our highest fatality corridors that we have out there, followed by local roads. Our major arterials typically carry the most traffic and typically carry them at speed. And we don't exercise our real stringent controls that we have on expressways, freeways, and interstates. So we end up with widely spaced, hopefully signalized intersections, and then we have the political pressure to maybe squeeze those together a little bit and maybe squeeze in a commercial access. And those things really drive that accident and fatality rate. And on the local system, I'd say it just has to do with lack of capacity to manage those things that, if we're talking about at a state system level, we have more tools and more capacity to do the work. Where I come from, A lot of the local municipalities are townships with part-time folks, one person doing road work. They don't permit driveways. They're lucky to keep the road traversable, much less managing how people connect to their system. All right. So how do we set reasonable goals for mobility and function? At any governmental level, the functional class system is a great starting point. The local roads, like we talked about, how do people connect to their lands? And then we look at our arterial roads. How are we going to be moving traffic? And how do we connect people to the large arterial freeway type systems for that interregional, interstate type traffic? And then, of course, connecting them from the local system into the major system. At WISDOT, we have an overall planning tool we call the SAMP, Statewide Access Management Plan. It's gone through several levels of ups and downs in how much we apply it to our roadway system, but I know at an application level in the regions where we're issuing permits and dealing with developers, our SAMP system is critical for us in our decision making and how we can communicate what has to happen. And the system is built into 5 tiers, and being a sound government agency, we can't just say 1, 2, 3, 4, 5. We have 1, 2A, 2B, 3, 4. And here's a little zoomed in view up in my neck of the woods near Eau Claire with the different types of tiers. So tier 1, interstate and statewide mobility. Tier 2A are high-volume, multi-lane, interregional mobility, arterial type corridors. Tier 2B are other, lower-volume, 2-lane, interregional mobility corridors. 3, regional and intra-urban mobility. And 4 is where we balance our access and land use. Access and mobility. All of them have a mobility aspect. At the state highway level, we are principally interested in mobility, and access becomes almost a compromise down in the tier 3s and 4s. The other things that you see on the legend are some of our proactive tools that we have and how we map those on our system. I actually didn't turn those segments on in the display, so just to keep the graphic a little cleaner for the SAMP details. But we have controlled access, a statute called 8425. If anybody's interested in understanding what that means, grab one of your WISDOT folks sitting at your table. We can talk about that. And then, of course, interstate, freeway, expressway designations, they're in there as well. Our tier 1, the interstate and statewide mobility. And what I'd like to focus on and have you just kind of keep track of is our overall crash rate. And these are segments. This isn't statewide average for these type of segments. These are just representative segments from the area that I'm familiar with. I just grabbed them. So they're representative of our area, what we get with our types of tiers. So this tier 1 interstate designated freeway, this is I-94 south of Eau Claire. We carry about 29,000 vehicles on this with the tier designation. Access management, there's a wonderful statement that says only at safely spaced interchanges. That's the only way you're getting on and off of a freeway or an interstate in our system, only via interchange. Our tools are, if it's a new road, we acquire property, we designate, and we restrict strongly to those interchanges. Our crash rate here is 25, and that's per million, or I believe 100 million entering vehicles. So it's a very low crash rate for a corridor carrying close to 30,000 vehicles a day. That equates, if you just run it out to make it simple to understand, about 1 crash per mile per year. Here's a tier 2A. Similar ADT. This is in the city of Eau Claire. And our access management tier 2A says that our access is primarily at grade public intersections with some interchanges possible at higher volume roads. So it's almost an expressway level type corridor. We shouldn't allow driveways to drop in on our tier 2As. We shouldn't do it. We should just focus our access to widely spaced intersections. And when you do that, of course, you consolidate your traffic to those, and they're most likely going to be signalized. Let's see here if I can orient myself. This is our state office building in Eau Claire right here. So this is a piece of road I'm on every week. We have issues that we had good arguments with the city about when we upgraded this piece of Highway 12 about the proximity to these signalized intersections. And it's interesting to watch the dynamics of drivers coming into this when we get a red light here and you got traffic coming out of the hospital and college just downstream here, large shopping complex here, how you watch the flow dynamics happen, and you see it back up, and you see people have to compensate for our poor design. You know, they're having to make decisions about, do I leave a gap so that guy can get through so he's doesn't have the back end of his pickup hanging out in that through lane. You see people being Minnesota nice here in Wisconsin to compensate for our lack of good design. But look at the crash rate. We've got a 10 times level. We've got about 5,000 more vehicles a day on this 6-lane corridor, but our crash rate went to 290. And that's right in this location. If I go upstream a little ways where we didn't do such a good job in spacing, we still don't have any driveways in here, but our crash rate goes up to 890, where our signal spacing drops down below a half mile. So along this entire corridor, crash rate goes from about 200 up to close to 1,000. And we've talked about this in different sessions, the functional area of the intersection, and the upstream at this type of a corridor that we were just looking at, the upstream functional area of that intersection is close to 600 feet with your average queues, and of course it can be longer when you get those longer queues. Where we run into trouble is when the functional area of the downstream effect of one intersection starts to overlap the upstream going into the next intersection. And of course, where you have the functional area of your side street intersection running into the close proximity of your cross frontage street. All of those things lead to relying on people being Minnesota nice, and that results in high crash rates, and then people aren't so nice. There are a lot of great tools that have been talked about yesterday, today, and I'm sure tomorrow through TRB resources and defining where the functional area limits are, how to calculate those things. So great tools out there. We just need to take advantage of them. Our Tier 2Bs, these are the more typically rural 2-lane, but higher volume, focusing on mobility. And these are the ones where, from our overall SAMP plan, we allow widely spaced, lower volume accesses. Occasionally, if there are commercial pockets on the corridor, if we don't have any other options, we allow those connections to come in. Either case, mobility should not be compromised. That's a great tagline at the end of that descriptor. Mobility should not be compromised. So this is a transload facility. We have a lot of frac sand mining up in our area. And this is an area where there are several mines within about 10 miles to the south of this facility. So they truck sand to this facility where they transload it to rail. And they send out, I believe, 3 to 4 unit trains a day of sand heading out to Dakotas and Texas. When they came requesting access to Highway 8 for this facility, we had a lot of different things we needed to deal with. This is their principal entrance, and I'm sorry you guys probably can't see this real well, but we went from basically a standard 2-lane, 55-mile-an-hour corridor, brought up into this area and had a very large right turn lane added and a very large left turn lane added, and a right turn lane for that local road that's across from their entrance. The reason these lanes became so long is because their rail system, actually, they store cars just past the driveway. So they're pulling at slow speed these unit trains down and backing them back up into their system to load and haul them out. But this is where they have siding tracks. So their access would get blocked by their own system, their own purposes, fairly routinely. And so in having a great conversation with their site manager about their processes, knowing that that was part of their system, that allowed us to determine how often that would happen, how many trucks per hour are coming into the facility. So we're going to have this stacking. We were able to calculate what the queue length was going to be in those worst case scenarios just from their trains blocking the road. And they saw that as a cost of doing business, and it wasn't, and I'll add this too. Most businesses have an interest in being good neighbors to some level. They don't want to have a bad reputation where they're trying to get permits for their business. So this facility was interested in developing a system that they knew would work. So they were good partners in getting this system built. Was that a 5-minute warning? About that? Okay. Tier 3, I'm going to back up. Crash rate on this, we have about 7,000 vehicles a day on this average. And I'll throw a little caveat on this. In our area with tourism, our ADTs are not reflective of what you'd expect today or what you would expect in February. We have high tourism variabilities in our traffic patterns up there. So a lot of turbulence, a lot of speed differential just based on what day you're out there, what month you're out there. But our crash rate's only 61 on this corridor, as opposed to think about that major arterial we just talked about. Tier 3, this is where we're getting down to where we're starting to allow mobility to become more of a compromise to allow more access to properties. Public roads, private access, safely spaced per design and operational standards. In Wisconsin, in our FDM, we have very nice, clear guidance on what we want for spacing. And it's really a best case scenario when we can get those. There's a lot of compromise that has to happen. You can see this lake development. There are, whoops, sorry about that. There are quite a few driveways. We have a boat landing across from a county road. This is a state highway with quite a few driveways dropping off to the lake. Interestingly, 5 years of crash history in this segment, we've had 0 crashes. Our ADT is about 2,900. We have some substandard spacing in our access, but we've done some consolidation where people were, 100-foot lot next to 100-foot lot where they do a shared driveway to create a betterment rather than we can't get our 500-foot standard, but how do we make it better? It's kind of shocking to see a 0 crash rate on a segment of state highway. The last one we'll look at here from a tiering is our Tier 4, which is basically where we're in a balance of access and mobility. And a lot of these are in urban areas, so they may not be considered a local road on the functional class system, but they're at Tier 4 where we're pushing for higher access on the corridor. When we have higher traffic generators, this is a CVS, this is a Holiday gas station, where we do median barrier, create right-in, right-outs because of the functional area of this intersection pushing out here. We needed to do things to protect the mobility coming into the intersection. Partnering with the city, when CVS wanted to come in, we said, we need you to be in agreement with us. When we go and want to have this developer install this median barrier, I don't think Holiday's going to be real happy with that. So city, you stand with us at this public meeting, and when we're talking to the CVS developers, that this is the way it's going to be, and that you're going to have to partner with us giving the bad news to the other folks. And the community worked with us. They were, interested in redevelopment of that corner with CVS, so they worked with us. And another element that comes into that is turning your access issues into planning initiatives, where you have these problem areas, identifying what the problem is, working out perhaps an MOU with the community about your long-range vision for that corridor, so you're both on the same page. Maybe they incorporate into their zoning, building permit approval process to meet that MOU. So, lovely, isn't it? But there's a great truth. Less safe is not necessarily unsafe. If the manager of this piece of roadway is going to allow another driveway, statistically that's less safe. But is it unsafe? So we need to pick our battles, choose where we can actually make a difference, make an improvement that's going to be worth our effort. This is reality. The more we put in, the higher our rates will be. But so is this. We'll get those redevelopment opportunities. This is right out here on East Wash, where opportunity for redevelopment occurred. The city, the state, the county, I don't know, they all worked together and they said, we can do this better. We don't need a driveway every 100 feet on this major 6-lane arterial. Let's work into our system where with redevelopment, we can make improvements for the long haul. So there it is. If we do it right, we're not going to win every fight, that's for sure, but we can make improvements. Identify your goals for your system. Get your right tools in place, have the courage to implement them, do the battles that you need to do, make it happen, and you'll survive the bear bite when that happens. That's a shot in my backyard, by the way. Cute little guy. Thank you.
Thank you very much, Jeff.